Hello. In this video, I'm going to talk about risk and return, the two concepts that are discussed in section 14.2 on pages from 593 to 597. First of all, we need to introduce one concept, which is called a discrete random variable. Basically, to specify a discrete random variable, you need a list of two things. First of all, you need to list possible outcomes of that random variable, basically what values it can possibly take in the future. And then for each outcome, you need to specify a probability with which that outcome is going to take place. And probabilities for all possible outcomes have to sum up to 1. Let's jump to an example that will illustrate what's going on. So in this example, we're looking at a stock and we're looking at what possible future dividend the stock is going to pay. So the random variable in the example is the future dividend of the stock. And that random variable takes 4 different values, $100, $200, $300, and $400, with probabilities of 0.1, 0.4, 0.4, and 0.1. And note again that the sum of the probabilities is 1. This always needs to be the case. Now, when we're looking at a random variable, we need to calculate two values for it. The expected value of the random variable, that means how much on average that random variable is going to be, and also the standard deviation of the random variable, a measure of risk of the random variable, a measure of the spread of the outcomes of the random variable around its average value. So let's do the expected or the average value first. The idea here is we're going to be calculating the weighted average. So we're going to take each possible value of the random variable and multiply it by the corresponding probability, and then add up these products together. So in this example, I have 4 different values. I'm going to take each of the values and multiply them by the corresponding probability. So 100 multiplied by 0.1, plus 200 multiplied by 0.4, plus 300 multiplied by 0.4, and finally plus 400 multiplied by 0.1. And if you perform all these calculations, you should get a sum equal to 250. What does that mean? That means that on average, the stock is going to earn $250 per turn. So in no single iteration will that stock earn exactly $250 in dividends, but if you repeat this random process multiple times, if basically you wait for the dividend to be paid a lot of times, then on average, the payment will equal to 250. So think of 250 as the kind of a center of this random variable, the average value that it will take over multiple repetitions of this random process. Next, let's look at the deviation. So now we know that on average, the dividend pays 250, and we want to see how spread out the outcomes of this random variable are relative to its center, which we call the expected dividend. So I'm going to take the expected dividend of 250 and subtract that dividend from every value from 100 to 400. So basically, to calculate the deviation, I need to calculate the difference between the possible value of the dividend and the expected value of the dividend. So it will give me negative 150 for the dividend of 100, negative 50 for the dividend of 200, 50 for the dividend of 300, and finally 150 for the dividend of 400. This is the distance between the realization of the random variable, the actual number that that random variable might take in the future, and the expected value of that random variable being 250. The next step that I'm going to take is I'm going to square all those deviations, because I ultimately want to get rid of the negative signs. I want to think of all distances being positive values rather than negative. And so 150 squared is going to get me 22,500. 50 squared is going to be 2,500. Same for the next one, 2,500. And finally, same 150 squared, 22,500. And then I'm going to take a next step and I'm going to calculate expected square deviation. So I'm going to take these values of the square deviation and multiply them by the corresponding probability. Because remember, my ultimate goal is to calculate how spread out the values of the random variable are around its expected value. So basically what I'm doing here is I'm calculating squared distances between the variables and the expected value, the realizations of the variable and the expected value of the variable, but I'm adjusting them by the probability so that I can calculate the expected deviation. So now I'm taking, let's see here, I'm taking this 22,500 multiplied by probability 0.1. So if 100 is the realized value of the variable, it will be 150 units away from its mean. And so the square distance is going to be 22,500 units from the mean. But that's only going to happen with probability of 10%. So this is the meaning of the first term. And then there are two terms in the middle where the square deviation is 2,500 and probability is 0.4. And finally, the last term has a square deviation of 22,500 and probability of 0.1. That gives me an expected square deviation of 6,500. That means that on average, your realization of a random variable, one number of the list 100, 200, 300, and 400, this is how far away it's going to be from the expected value of the random variable equaling 250. Final step, take the square root of the expected square deviation, and this is what we're going to call the standard deviation. The square root is going to be approximately 81, and you can think of it as the average distance between the expected dividend, the mean value of the random variable, that is 250, and the realization of the random variable. So if that expected distance is low, that means that the actual realizations of the random variable will fall close to the expected value of the random variable. If that standard deviation is getting larger, that means that the actual realizations are actually going to be falling far apart from the mean value of the random variable. Okay, now to sum things up, we have a random variable here, a future dividend that the stock is going to pay. That future dividend has 4 possible outcomes, and each outcome comes with a specified probability such that all these probabilities sum up to 1. The expected value, or alternatively, the weighted average value of the outcomes is 250. The standard deviation of this random variable is 80.6, almost 81. So on average, the dividend that you will see in the future will differ from 250 by $81. Sometimes it will go 81 above, sometimes it will go 81 below, but the average value is just 81. This is the distance between a realization of the random variable and its mean. In the next video, I will show you how to compute the mean and standard deviation in Excel, and then how we can use those computations to compare different random variables. Thank you.